One of the contributions of this research is that we identify at the global scale which are the areas with the greatest potential to sequester carbon.
This is The Butterfly Effect, a podcast that shows the big impact a small action can do. Tali Orad is talking to those special people that make a difference with nature and trees.
Welcome everyone to The Butterfly Effect. My name is Tali Orad. I'm your host and your butterfly here. Returning specific ecosystems that have been replaced by farming to their natural state in all continents worldwide would rescue the majority of land-based species of mammals, amphibians, and birds under threats of extinction. Such measures would also soak up more than 465 billion tons of carbon dioxide, according to a new report released recently. 27 researchers from 12 countries contributed to the report, which assesses forests, grasslands, shrublands, wetlands, and arid ecosystems. I'm excited to be speaking today with one of them, Pedro Brancalion. Welcome to The Butterfly Effect, Pedro.
Thank you, Tali. It's a great pleasure for me to participate in this podcast.
So let's start with you sharing a little bit about yourself. What do you do, and what was your role in this research?
I'm a professor of forest science in the University of São Paulo, Brazil. I study different approaches to restore native ecosystems and especially tropical forests. I spend most of my time finding ways to make restoration a more efficient activity, which could be more cost effective and then more feasible to be implemented as a solution to climate change and other environmental problems. And my participation in this research was I participated in the development of the models that were used in the analysis, as well as to define which criteria of prioritization we should use. And this project was initially based in a project developed at Atlantic Forest, where I worked. This global analysis was some way initiated in a more local biome scale analysis that we developed here in Atlantic Forest.
By restoring a third of the world's ecosystems in priority areas and protecting ecosystem, we can reduce carbon emission that has built up in the atmosphere over the last 2 centuries by almost a half. How does your research suggest that we do that restoration?
One of the contributions of this research is that we identify at the global scale which are the areas with the greatest potential to sequester carbon. So the opportunities for sequestering carbon through ecosystem restoration vary spatially across the globe. And we have some ecosystems that are more efficient to achieve this objective, like tropical forests. They grow pretty fast and they accumulate a lot of carbon in their biomass. By identifying these areas, we can maximize the role of ecosystem restoration for mitigating climate change. And we can also consider that this was a conservative analysis because we only considered restoration in areas that were already converted to agriculture or pasture lands. But we do have another great potential to restore the degraded or young forests. So most of the tropical forests covered globally is composed of secondary forests that regenerated after conversion to anthropogenic land use.
Right.
So if we consider the stock of carbon in these young or degraded forests, we can also have an even greater potential of carbon sequestration through ecosystem restoration.
You were talking about some specific areas. Can you define them?
We explore this potential in all different types of ecosystems because our main idea in this paper is that if you want to achieve multiple objectives, you must select multiple ecosystems.
Right.
So we have to address other types of benefits for restoration. But when you look at the global maps of carbon sequestration potential, we have to recognize that tropical forests and forests in general, they maximize this benefit.
You mentioned not just tropical forest, and your study brings a broad approach regarding the current model of land use and the opportunities involved in the ecological restoration of areas of low productivities without harming food production at the global level. How can these two models coexist in practice?
We have different types of land use occupying the areas where native ecosystems were converted to agropastoral land use. And they vary a lot in terms of productivity and contribution to food production. Just to give you numbers from the region where I work, so here in Brazil, for instance, we have 211 million hectares of extensive pasture lands, which accounts for like 75% of all anthropogenic land use in the country. But if you sum up the crop area, like we have 30 million hectares of soybeans, 15 million hectares of maize, 10 million hectares of sugarcane. So all of the, let's say, more productive land use, they account for 60 million hectares. So we have a lot of areas mostly occupied by extensive cattle ranching that could be allocated to some type of restoration without harming the global food production system. Although we have to find ways to accommodate restoration areas in extensive pastureland areas because we still have a global demand for beef production.
Right.
There are clear ways in which we could maximize beef production in the already existing areas and at the same time save areas for restoration.
Yeah, it's interesting that you mentioned those areas because the way I see it, the results of your work has identified important areas for ecological restoration from the point of view of biodiversity and cost and reduction of the effects of climate change. But coincidentally, a large part of the poorest population lives in these regions, right? Considering the need for massive investment also to adapt to climate change using forest, what are the main opportunity that we can explore with these results in relation to people and the communities?
Yeah, I see that restoration can become an alternative land use for these communities because what have happened at the global scale is that these communities, they have been pushed by intensive agriculture to the marginal areas for production. So the most fertile, flat, good areas for large scale agriculture have been concentrated on few landowners. So few landowners and few agricultural companies, they dominate most of the areas that are good for agriculture. The communities, small farmers, indigenous communities, they cannot compete with the big farms. But today, they have to compete because we have a globalized food market, a globalized agricultural commodity market. So they are in a difficult situation of having sometimes to live on food production, but at the same time, they have to compete with the big farmers, which have the largest lands and access to knowledge and access to finance and all of this different kinds of support for intensive agriculture. So when we bring an environmental product, let's say community or small farmer group or indigenous group, they may benefit from it because they are in a better position to deliver environmental benefits to society, but society must pay for it. So the challenge now is how to create models that would financially reward the communities by the environmental services they can provide to community. And then restoration is part of it. Restoration must be a financially viable land use for communities, not only a favor they do for the global economy or global society.
Yeah, and that's the $1 million question to find a way to give them a different way of income and a different way of supporting themselves. So they will find that as a benefit versus trying to say, I can't compete, I'll just do what I can.
Yeah, but sometimes we have the answer, but the implementation of the answer is not that easy. So for instance, carbon has been a clear benefit that local communities can provide to the global markets. So like indigenous lands in Brazil or small communities in Western Africa, they have a lot of carbon stock in their lands, and they can sequester much more carbon if they implement restoration projects there. But the global price of carbon credits is far away too low to compensate their losses.
Right.
So at the same time, the global economy, they want to foster the carbon markets. They don't pay enough. So then they will never create a real market with supply and demand. So the market will be just a partial, the money that communities get from carbon credits will be very small compensation.
Right.
They're not really receiving enough money to support land use conversions.
You mentioned the carbon in the land. I want to talk a little bit about that. I'm assuming you're referring to the soil carbon and the below ground biomass. They are so important part of the research. Maybe you can start explaining a little bit about what soil carbon and the below ground biomass before we dive in why they are so important.
Soil and below ground carbon stocks, they are really important. In some ecosystems, it can constitute even larger stocks than above ground carbon stocks. But at the same time, they are difficult to quantify. So for instance, if you plant trees in a site, the trees grow, you will increase the stocks of carbon in the above ground biomass and also in the biomass of roots, for instance. But not necessarily you are impacting soil carbon stocks. So although it's important and we have to account for it, it's more difficult to include soil carbon as part of payments for ecosystem services.
Right. Even though that 58% of soil is carbon. So it's great asset for humanity to use it. But you say it's hard to calculate that.
Yeah, it's hard because sometimes, for instance, you can restore an area, you can invest there, but you may not necessarily change carbon stock. The soil may continue to have a high carbon content just because it is a clay soil, and clay helps to bound the carbon molecules in the soil. So even if you restore an area, the clay content of your soil will determine its carbon stock. So it's difficult to control for the additionality of soil carbon through ecosystem restoration. I'm not saying it's not important or that it should not be done. I'm just saying that it's challenging, it's tricky, and we don't know yet how to do it precisely in order to justify payment for it.
So we are counting trees for that matter.
Even measuring carbon stocks in trees, it's challenging. You need good equations, you need good models, good forest inventories. And also restoration is a very complex activity. It's not because you planted the trees that you get the carbon. So that your trees can die or they cannot grow well because of competition with grasses or because of soil degradation and a myriad of factors that may prevent restoration or of being successful. So even in the case of trees, it's not easy to determine their carbon stock or even to predict it in the future.
And one of the aspects for those restoration is biodiversity, and it plays a huge role in the study. Maybe you can share with us some of the benefits to biodiversity conservation.
Restoration can play a clear benefit for biodiversity conservation because it may reconnect ecosystem remnants that were isolated in the landscape.
Mm-hmm.
A large share of the predicted species extinctions will happen because these species, they are isolated in remnants. The gene flow among populations is quite limited. And at the same time, these populations, they are usually very reduced. The species is represented by a quite small number of individuals because of the reduction of the habitat cover. So restoration may help to expand habitat cover, but also to reconnect isolated populations. So then you can reestablish a more healthy ecosystem structure to support that species and their population. And without restoration, extinctions will be just a matter of time because we still find these species in the remnants. We can count them. We can take photos of them, but they are in an ongoing process of genetic erosion, of population depopulation. So it's just a matter of time to get them extinct. So restoration can help by bringing a new breath to these species and offering them new opportunities to persist, even in human-modified landscapes.
And how many species are expected to become extinct if we do not follow the guidelines of the research?
If we restore the 30% of the most important areas for restoration, we could prevent the extinctions of 70% of all of the threatened species globally. Wow. So it's a major contribution. So we are not saying that other interventions are not needed to avoid and to control for biological invasions, overexploitation through hunting and overfishing and so on. In fact, the main driver of extinctions is habitat loss. So the species, they don't have where to grow and to reproduce and to survive. So restoration can recover the habitat and reestablish part of the connectivity lost with the conversion of natural ecosystems.
So what are the guidelines to actually go and do it? You mentioned 30% of the area has the most impact on everything.
Mm-hmm.
How do you come up with that guidelines or definition of this is the best place to do it? We should focus on that areas and that areas only, or at least start with them.
So first, we created global maps of the variables we were interested in. So we first created, for instance, a global map of the species that are at risk of extinction. Mm-hmm. And at the same time, we can create a global map of predicted carbon stock in the vegetation. Mm-hmm. We used a global map of the land opportunity cost, which represents the profit that land users, they get from agricultural land use. Then you can combine these maps in many different ways, considering, for instance, the distribution of the areas in different ecosystems. So without considering it, so we created more than 1,000 maps combining the same variables in completely different ways in order to present some type of appropriate solution for decision makers.
And your research assessed 2,870 million hectares of ecosystems worldwide that have been converted to farmland. What do you see as the biggest challenge here?
I'm an agronomist by training. For me, the biggest challenge is how to create space for restoration at the same time we are demanding more space for food production.
Right.
So in many cases, we continue to use lands for food production and not necessarily food, right? Sometimes we produce agricultural commodities that are not necessarily used for food. So we are using lands that does not have good conditions for it.
Right.
And we should invest more resources and technology and knowledge to improve production in the areas that are prone for agricultural production.
I see. And your research is giving guidelines to countries. I'm assuming it's in a way a political issue that needs to be resolved, right?
For sure, it's a political issue because,
Yeah.
again, I can give you examples from Brazil. We are still converting large portions of the Amazon to expand cattle pasture.
Mm-hmm.
But there is enough area for improving, like by simply adopting best practices in the use of the land. If the government doesn't consider it as a national issue, the
Mm-hmm.
decisions of individual farmers will always push deforestation forward
Right.
because they always will want more land for their own use. So we have perverse incentive for continuing to push deforestation frontiers for getting individual profits. While at the same time, if we don't consider it as a national, as a strategic issue, we may never create the appropriate conditions for accommodating higher agricultural production in the areas already converted for it and improving the use of these lands in order to achieve the needs of higher production over time.
Mm-hmm.
Critical issue is how we can accommodate restoration into these national and global contexts that are demanding more land for achieving the global demands for agricultural products.
Let me ask you this. Assuming we were to implement all your suggestions and all your guidelines from this paper,
Mm-hmm.
when will we start seeing the effectiveness of this all on our planet?
Well, we can see the effectiveness of it in a few years, especially in ecosystems where the plants they can develop fast, like tropical forests.
Mm-hmm.
You can clearly see a major difference in the structure of the vegetation within 2 or 3 years. So here the rule is that when you plant your trees and you maintain them for around 3 years, after it will be a self-sustaining forest somewhere. The trees will grow, the invasive grasses will be suppressed by shading, and then you can see with time the native species returning to the restoration area. You can see the trees growing and stocking carbon. You can see improvements in soil water infiltration and in a lot of different variables that attest for improved environmental management.
Mm-hmm.
So the changes are pretty fast, at least, as I said, in the ecosystems where vegetation develops fast from restoration interventions.
Right.
In other ecosystems, it can take much more time, like in coral reefs or grassland communities. So these ecosystems, they respond more slowly to restoration interventions. But it's not because of it that we shouldn't restore them. It's just a matter of balancing the expectations you have with the capacity of these ecosystems to deliver the benefits you want.
I love that you give us that hope that certain areas it will be faster than the others, but it doesn't mean that we don't have to. And I like that power to the people, because politically, unless we do stand in power, there is not much we can do. But there is actually some that we can do. And you mentioned some of the consumption in terms of food, right?
Mm-hmm.
Anything else you think the regular John Doe that is listening that says, well, I can vote and change, but maybe there is something else I can do. What do you think they can do?
Oh, there are a long list of things they can do. So as you said, first, they could vote. Secondly, you can evaluate how your consumption patterns, they influence the demand for land.
Mm-hmm.
So you can analyze your consumption patterns, not only in terms of the wood you use in your furniture or to build your house, but also from where your coffee comes. and also how often you eat beef and other products that demand more lands. They are more associated to deforestation, land and ecosystem conversion to anthropogenic land use.
Right.
And also, you can consider certification, farms that are certified. And as part of certification, the farmers, they have to restore some lands. So usually the agricultural products that are certified, they are more environmentally friendly, and they do support restoration and protection of native ecosystems. And finally, there are many different NGOs and community groups and organizations that are dedicated to ecosystem restoration. And they require funding, they require support, they require knowledge. So there are many ways in which everybody could get involved in this process by donating fund money to some of these organizations, by helping to disseminate their work in your in your social group, or by dedicating part of your time and to find solutions to this group. So like in my case, I'm a researcher. So I use all of my capacity to help restoration by developing novel approaches, novel ways to promote tree planting and natural regeneration, and more cost-effective restoration approaches, but also trying to guide decisions, working with spatial prioritization analysis, public policies, and other ways to improve decisions, improve restoration.
I see. Now, after talking about biodiversity, I feel like it's a not so fair question, but I'll ask it anyway. What is your favorite tree?
My favorite tree is the Brazil tree. It's an interesting story. When the Portuguese, they first arrived in Brazil in 1500, they were looking for gold and silver because they were exploiting these metals in Central America and other parts of America, and they didn't find any of them. And then they had to make money in the new land. And they found that they could produce a kind of red ink with the wood of a local tree. And the red ink was quite valuable by that time in 1500 because it was the color of the king, the queen. And then they started to exploit this species for producing this red ink. And Brazil in Portuguese is amber, like the color of amber,
right?
You know?
Right.
And then that's the name of the tree. And because of this tree, our country got this name, Brazil.
It's fascinating.
So Brazil is the name of the tree, the first tree heavily exploited by Portugal in the case when they first arrived here in 1500. This species is a threatened species today. You can find really small populations of this species. It was heavily exploited. But at the same time, the wood of this species is the best one for producing violin bowls. So there is a big industry that relies on pau-brasil wood for classic music. So it's a much more, let's say, noble use of this species. And I really like it because it's not only a tree species, it's linked to the history of my country, and also it demonstrates how we can lose from species extinctions. So the pau-brasil today is not important for ink. You know, we have all kinds of artificial ink, but then we have a different use for it, which is much more noble, and you cannot replace it by any artificial violin bowl. You rely on the wood. So it shows that we should not consider that we know today the value of a given species. We have to protect it for future generations, which can find a much better use of it.
That's a beautiful story. How do you say tree in Portuguese?
Árvore.
Ivory.
Árvore. Yeah. Árvore.
Thank you, Pedro, for joining me at the Butterfly Effect. And thank you for sharing with us your important research and all the stories. I'm looking forward to seeing how it will be executed globally.
Yeah, me too. Believe me. I really want to see this research being put on practice.
And thank you, everybody, for joining us today. We are all beautiful butterflies, each in his and her individual ways. I wanted to thank you for joining me today in this episode. I really appreciate you coming on this journey with me, and I hope to see you next time. And remember, it only takes a small action to make a big difference. Be a butterfly.
And that's all for this episode. Thank you for joining us today. Please subscribe to hear more of our stories of change.